Yes, my dear student, there is question on the board. Very important question for class 11 and for competitive exam also. A man stands on rotatory platform with his arm outstretched horizontally, holding 5 kg mass in each hand. The angular speed of rotation of platform is 30 rpm. The man brings his arms close to his body, changing the distance from 90 cm to 20 cm. The moment of inertia of mass of man along with platform is 7.6 kg meter square. What is the new velocity of rotation? And number 2 is the kinetic conserved. And if not conserved, then how do you account for the difference of the energy? I may explain with the help of little diagram. It is platform here, rotating, and here is a man standing on this platform, having his hands outstretched. Initial distance 90 centimeter. 5 kg this way, 5 kg here. Moment of inertia of man and the platform is 7.6 kg meter square. Now the man bring his arm close to body. This distance 90 centimeter. 90 centimeter. Now he stretch his hand and bring the body close. This distance become 20. So what is the new angular velocity? Actually, the man has applied his own muscular force to bring the man and this platform is system of two bodies, and if no external torque, since no external torque acts here, so angular momentum conserved. पहली बात तो ये angular momentum is conserved. That is I2 omega 2 equal to I1 omega 1. Five kg each mass, 90, 20, this. So what is omega 1? Actually omega 2 pi n is there. So first of all let me find out omega 1. 2 pi into 30 rpm. 30 rpm is 30 by 60 rps. Now it will be radian per second. Please solve the question very carefully. 1 by 2, it becomes pi. Omega you have to find out. Now, moment of inertia, I1. I1 here equal to 7.6, the man and this plus 5 into 0.9 square is of mass 1 and they are 2, so into 2. So this is equal to 7.6 plus 10 into 0.81, 0.9 square, 0.81, 8.1, 7.6 plus 8.1, it is 15.7 kg meter square. Now what is I2? What is I2? Let's build up this. So I2, in fact I2, 7.6 remains fixed, only the variation in the moment of inertia of two masses, that is 0.2 square. It is 7.6 plus 10 into 0.2 square. यहाँ मिस्टेक होती है बच्चों से, वो 0.4 हो जाते हैं. 0.2 means 0.2 into 0.2, 2 to या 4 decimal 2 के बाद. Be very careful. I will tell you the mistakes which we do. 0.04. So it is 7.6 plus 0.4. It is 8 only. 8 kg meter square. Now your problem has become very simple. You have to find out omega. Omega 1 is pi, means 1.3.14. You can write in pi, no problem. Radian per second. तो ओमेगा 2 निकालना है, तो I2 ओमेगा 2 इक्वल टू I1 ओमेगा 1. I2 is 8, omega 2. You have to find out I1 15.7, omega 1 3.14. I mean 3.14. So omega 2 equal to 15.7 into 3.14 upon 8. You know 3.14 is pi. And this is 5 pi in fact. This thing is 5 pi. 1.5 but does not matter. I mean, actually pi means 3.14 divided by 2 होता है 1.57. It is 15.7. तो 15.7 कितना होगा? And pi is equal to 1.57 और n बराबर 15 sorry 15.7 upon pi 3.14. How many times? 5 times. 5 for 20 years. 5 हो गया ऊपर. तो दिस इज 5 पाई लिख सकते हैं इंटू पाई अपॉन 8, यानी कि इट इज 5 पाई स्क्वायर अपॉन 8, लाइक दैट इफ यू अवॉइड मल्टीप्लाई. तो ओमेगा 2 इज दिस. यू कैन सी पाई स्क्वायर जो है नियरली 3.14 स्क्वायर. 3.14 square in fact comes out 9.87 nearly. 9. So you can write here that 5 upon 8 into 9.87. How much? 5 7 35 3. 5 7 35 carry 3 और 5 40 और 3 43 4. 5 9 45 और 4 49 upon 8. 8 6 48 1. Now 49.35 divided by 8. 8 6 48 1.3 1 8 5 nearly 8 7 you can write near 6.2 radian per second. This is new angular velocity, initially 3.14. So now you have to find out initial energy. Initial energy जो है वो हाफ I ओमेगा स्क्वायर. हाफ I था 15.7 into omega 3.14 square. 3.14 square. So it is 2 7 14, 2 8 60. This is much into 9.87 square of 3.14. You can do it, and nearly it comes out to be 77.4. If I take it 8 and 10, so nearly it's 77.4 answer. Joule. Now final energy, K final, half I2 omega 2 square हाफ I2 था हमारा 8 ओनली, ओमेगा 2 था हमारा 6.2 है भाई, 6.2 स्क्वायर। तो हाउ मच इट इज 4 into 6.2 square. Don't hesitate in multiplying. 6 to the 12, 6 to the 1, 6, 37, 4, 4, 8, 3, 38.4, 38.44, 4, 4 the 16, 4, 4, 16, 1, 17, 4, 8 the 32, और 1, 33, 15, तो nearly 153.76 joule. You can say 157.154. So it is very much greater than this. So kind energy has increased. So kind energy is not conserved. From where this increase has come? How does this increase is there? So increase in potential kind energy, increase in kinetic energy is equal to work done by man using his muscular energy. When he brings his hand close to body, he has to apply force to stretch the masses inward. So he uses his muscular energy. This is a very important question here, and a lot of questions are based on this fact. One more question is there in your book. A child stand on platform like that. If the system is there and no external force act, environmental remains conserved. I will do one more question here, which is very simple for you and good for your preparation also. Here is inclined plane. Here is inclined plane. The length of this inclined plane is 20 meter. The length of inclined plane is 30 degree. This 30 degree inclination, and this is 20 meter. A spherical body, cylindrical और कुछ भी है, rolling body. Sphere, sorry, not sphere. It is sphere here. It is sphere here. It starts rolling down, and when it comes at this point, so what is the velocity of central mass? What is the calculate the velocity of sphere at the bottom? G9.8. G9.8 meter per second square, and due to friction. Due to friction, there is loss of 20% in the energy. Energy of sphere lost during friction on the surface. So how to solve this question, dear students? Simple question. Actually, energy here is in the form of potential energy, mgh. So how much is this h? So h upon 20 from trigonometry equal to sin 30 and sin 30 1 by 2. So 20 into 1 by 2. So it is 10 meter height. So total energy at the top of plane is equal to mgh, am I? M into G9.8 into H10, so it is 98 M Joule. M is the mass. When it reaches here, it will have rotational motion as well as linear motion. तो kind energy of sphere at bottom. Actually, you are not with me. Otherwise, I have asked you to do the question here. So that is half mv square. Values of central mass plus rotation kind energy half I omega square. Half I omega square. Do you remember the moment of inertia of sphere about diameter? I is the moment of inertia of sphere. I hope you remember. It is 2/5 mr square. mr square and omega equal to v square by r square. तो ये कैंसिल हो गया. M सॉरी इसको लेता हूँ. तो how much m is there? It is half mv square plus these two cancel. It is 1/5 mr square. So how much is this total? You can solve it now. The total energy is final kind energy at the bottom. 10 is the LCM. 5 plus 2, 7 mr square. And this energy is 20% of this. No, sorry, 80%. Because 20% is the loss. 20% is the loss. So this energy here is 80% of this. Since you can write here 20% of energy lost. So 7/10 m v square. V square is equal to 80/100 of 98 m. 98 m. Very simple calculation, dear students. This 10 cancel, 8 cancel, m cancel. So v square equal to 8 into 98 upon 7. How much is this? 14. 14 8 ja 112. Square root of 112. हाँ यही होगा. तो v square equal to 112 और v equal to under root 112. It comes out nearly 10.58. You know how to find square root? Meter per second. 112. Do you know it or not? नहीं जानते क्या होता है. If you know, very good, but I am telling you one thing here. Under root 112. So pair is this. 1 1 ja 1. 0. It will be 2 here. You will take now 12. If you take one time, so it is 21 more than this. So you put here 0 and 0. Put decimal and then take 2 0 here. And then it will be 5 times. 5 5 are 25. 5 is 10. It is 5 or 7 or 1. 2 0 again. Now it will be 5 5. We had 5 here. The 0 1 2. And now nearly 2 8 are 16. 8 times. One thing more for your benefit. Sometimes we ask what is the under root decimal 0.4. So in hurry, child tells us, sir, 0.2. If you multiply the 0.2 into 0.2, 0.04. So square root of 0.4 is not 0.2. In fact, 0.4 is not perfect square. The square root of 0.4, how to find out? 0.4. Decimal, after decimal we make the pair from left to right. Before decimal we take right to left. 0.66, 36. 4 0 0. And then 12, 3 like this. Dear student, in one seminar I was there as a principal there, and teachers were totally playing blame game. One teacher was saying, how can we teach the students, they don't know how to multiply, how to add. But you tell if they have forgotten, simply. So please work hard. I will meet again with more numerical problem for this chapter. Some very important numericals are there left, which will solve here.